Okay, so I know you took a test, and yes, I am still giving homework on the day that you take a test. I thought I couldn't waste the opportunity to review some of the stuff that you were taught in 8th grade and kind of use it as a prerequisite for the next unit. A prerequisite means that these are some skills that you will need to have so that you'll be successful in the future. So this is a short assignment, but let's just talk a little bit about the rules of exponents. So I'm not going to work out every problem on here, but I'll get you started, and I chose which problems I'm going to work out very carefully so that they should be able to help you do the rest of the paper if you understand the rules. So here's the first rule. We got sick and tired of multiplying by the same thing over and over and over again. 8 times 8 times 8 times 8 times 8 times 8 times 8. That is awful. So mathematicians invented a shortcut for multiplying by the same thing over and over again, and that is exponents. So the number that we're multiplying by over and over again, that's 8. Now, how many 8s do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9 of them. We have 9 of them being multiplied together in a row, and so the exponent is a 9. That's what it means to repeat multiplication over and over again. How many times? That's your exponent. Okay, so for that should help you with number 2 especially. I think you can figure out number 3 as well. But when you look at number 4, I'm trying to show you here that you don't need to write them all out. Let's imagine what's happening. If I were to write out x to the 18th power, that would be x times x times x. It would be 18 x's in a row. Holy cow, I'm not even going to count them. That just takes too long. But you get the idea. 18 x's being multiplied together. And then I would multiply by 2 more x's. So how many x's would I have being multiplied together? I would have 20 of them. And that helps you make sense of the rule that when you are multiplying two exponential expressions together and they have the same base, you can add the exponents together. 18 plus 2 is 20. Okay, so then what happens when you're dividing? You're dividing and they have the same base. That's the number that's being multiplied over and over again. Well, I could write out, but I really don't want to, but I could write out 24 m's. Oh, you can see why we invented something else, because that would be awful. And I don't even have enough room. So dot, dot, dot. That keeps going forever. Imagine there's 24 m's. And then on the bottom, we'd write out 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's an m. Well, I know that m divided by m is 1. So every time I have a pair of m's like this, that's just going to become a 1 times 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 1. And so all of these m's right here, they all just become 1. And 1 times anything is that number, but how many m's do I have left after all these m's divide away? Well, it's almost like saying I have 24 minus 10. And so I must have m to the 14th. There must be 14 m's left in the numerator after I make pairs out of the bottom with the top. I hope that makes sense. So when you're dividing exponential expressions, you should subtract the exponents if they have the same base. So 24 minus 10. Okay, here's another one. This time you need to distribute. You have a number smashed in front of parentheses, and that's what it means when we distribute. So you are going to multiply w to the 4th times 3w. That becomes, I'm going to write it out, 3w times w to the 4th. And then we'll also have over here negative 12 times w to the 4th. That one's a lot easier to deal with. Okay, so what does this part right here remind you of? That reminds me of kind of what we did up here, or maybe even on the other page. We have 1w and we're timesing it by 4 more. How many w's do we have all total? We have 5. So that becomes 3w to the 5th minus 12w to the 4th. So another way to think about that is there's a little invisible 1 here. We never write that it has an exponent of 1 because everything is being times by itself one time. So we kind of get lazy and that kind of goes away. But if you will remember that when it's invisible, it's not a 0 exponent, it's a 1. That means that you have 1 plus 4, which is 5 w's being multiplied together, just like that. That's w to the 5th. So we had 3w to the 5th minus 12w to the 4th. Can I combine these two? Can I say it's negative 9 something? No, you can't. They don't have like terms. So this has a different exponent than this. Those are not like terms. So you can't combine them. So that's just your answer. 3w to the 5th minus 12w to the 4th. Done. Okay, let's do 2 more for you tonight. When you have a power raised to another power, that's when you multiply. And let me just write out what this actually means here. You have 2, see that 2? There it is. You have 2 groups of x to the 6th, y, z to the 5th. So I'm going to write that out. Here's 1, x to the 6th, y, z to the 5th. And that's being multiplied by another one exactly like it. That's what the 2 means. There's 2 of them being multiplied together, right? Think about that. Just like how 8 squared equals 8 times 8, and x squared equals x times x, then x to the 6th, y, z to the 5th squared must equal one of them times another one. So then this becomes one of those earlier problems where we are actually going to combine like terms by multiplying. Everything here is being multiplied. There's multiply, whoops, let's not erase, let's draw. There's a multiplication sign in between every one of these. So we have x to the 6th times x to the 6th. So I'm going to write them next to each other just by doing a little bit of commutative property. And let's see what that means. X to the 6th times x to the 6th. If I were to write out all 6, then that would be from this one. What if I were to write out 6 more? 1, 2, 3, 4, 5, 6. How many x's total do I have being multiplied together? I have 12. And you could do that with all the others. There's a 1y times another y, which is y squared. And then z to the 5th times z to the 5th, that means you had 5 and another 5. And they're all being multiplied together. So there are 10 z's all together. Ooh, excuse me for the yawn. Number 14. You're supposed to evaluate this if x equals 2. So I've got 30 times 3 to the 2nd power. If x is 2, then I can replace the x with a 2. Well, 3 to the 2nd power is 3 times 3. So this actually becomes 30 times 3 times 3. And that is 270. And that's the answer. It's the last one. Good luck on this little review homework. I hope it helps you dust some cobwebs off of your exponential expressions in your brain.